Okay, ladies and gents, what we're looking at is a data sheet for a Year 11 cohort and their Level 2 outcomes. That in this data sheet we have reference to their feeder primary school, sex information, SEN, and free school meal. And then we have a whole bunch of columns going across here, which are the individual scores for all of their subjects that they undertook. And then on the right-hand side, we have the total point score, which is just a summation of all of the other columns, all of the other data for this learner. So the very first thing I'm going to do, actually, is I'm going to hide away, just by highlighting the columns, all of the data. I'm going to hide away all of the data other than the total point score. Yeah? Zoom in a bit so we can see what we're doing. And we've now got feeder, sex, SEN, free school meals, and total point score. And one of the very first things, given a data set like this, that you may well be interested to find out. It could be just for your subject, so not just the total point score. So as a head of science, maybe I'd be interested in looking at core and additional science. The first thing you might want to know is to start comparing the data for, say, the average for sex, SEN, free school meal, and so on and so forth. So Excel has a number of ways of doing this, some of which are more or less interesting and valid for what you might want to consider. So the first thing is, if we consider sex, and I want to find out an average value for, say, male and female. So sex, and we're looking at, say, the female scores and the male scores. Just rough and ready. I'm going to delete these in a minute, but the rough and ready way of doing this. So if I want the sex for females, the first thing I would need to do is to sort the data to push all the female scores to the top. And then I in some way would select all of these scores down here, keeping an eye on the sex column until I go from females to males, which is there, isn't it? Row 62. And if I highlight all of the data, what Excel does is down here in the status bar, it actually averages it for me automatically. So that's 541. So I could go back here and I could say females 41. In a similar way, I scroll down the list here until I find the males, and I highlight all the male data, and I say that the average for the males is 498.8, so let's say 499. Okay, now I've hard-coded that, and I've got the difference between the males and the female. Let's say it could be in your subject. And I want to do a similar thing for the SEN information, and I want to split it up into, yes, those people who are on the SEN register, and those people who aren't, the ALN register, whatever we're calling it. So I would do a similar thing, where for the SEN, I'm going to order it by nose at this time. Okay, so we're going to get the values for nose, and I could drag out the values for nose till it changes to yeses, which is there, column 63, no, column 62. And I'm going to say that that's 603.4. So for no, it's 603. And then I could scroll down the list until I find yeses. Where are the yeses? The yeses are here. And I could drag out the values for yeses. And I've got 442. So I can scroll back up, 442. And I could do the same thing for free school meals. And I've got yes for free school meals, no for free school meals. So this time I'm going to sort it by free school meals. And I'm going to drag out the values for no's. And the values for no's on free school meals are 623.8, so let's say 624. And the values for yeses then, scroll down the list until we get to yeses, drag out the yeses, and we've got 432. Okay, so I've concocted and I've manipulated the data in Excel, and I've got some very rough and ready figures for the averages between these two things. That's okay, I guess. It was a bit of hard work, wasn't it, in terms of sorting the data each time to get it. And actually, this isn't live, and if any of the data over here changed, if these numbers here changed in the total point score, these values here wouldn't be linked to it. And actually, every time I had to do this, I had to sort the data. So if I was trying to do it for all of the subjects, you know, the 50-odd subjects that are hidden away here, it'd be an awful lot of work. So I'm going to can that method of doing it. And what I'm going to do up here, I'm going to insert 3 rows, yeah? And here I'm going to say sex, SEN, and free school meals. So this is still a rough and ready kind of dirty way of doing it. But for sex, we've got sex broken into female and sex broken into male. And for SEN, we've got yes SEN, no SEN. And for free school meals, yes and no on free school meals. And then in this column here, in BK1, I'm going to put the average value for the sex, if it's female, for the total point score. Unfortunately, Excel has a formula for doing this. It's AverageIF. And the AverageIF formula, it looks at a range, so in this case a range of sex information, compares it to a criteria, which is it F or M in our case? And if it is F or M, it then averages the numbers. So my range is from here to here, my range of sexes, okay? And my criteria, I'm going to say for this one, I'm going to pull out the females. And if it is a female, I want to average this data in the final column. Close my bracket. I compute it, we get 541. Let's make the numbers slightly less. We get a whole number, put in the nicest column. So the average value for females is 541. If I copy this formula over to here, you know, Excel moves things around. So what I'm going to do is I'm going to put a string value in front of the B's and a string value in front of the BJ's over here to in effect the formula. And when I copy the formula from here to here, the formula will give me the same answer because everything's been copied across. Except in this column here, I want to change the F to male, to M. And it's telling me it's 499, which is the same value that we had previously. So the value for the females is 541, the value for the males is 499. But the beauty of this method is that it's a live figure. Yeah. So if I go and sort the data by different columns, the data doesn't change. I'm going to change something but put it back. But if I change the value for this female here from 615, I don't know, to 800, the value up here changes. Put it back to 615. The value here changes because these are calculated programmatically from the spreadsheet. So if we do the same thing for SEN, SEN is in column C. So it's the same formula, really, except my data's in C. So I'm going to use the AverageIF formula. And my range of SEN information is the next column. My criteria is yes. And if it's yes, I want to pull the data from the final column. Okay. Close my bracket, process the formula. Reduce the number of decimal places, pop it in the middle. So the average for SEN of yes is 442. As before though, I'm going to copy the formula from here to here. So I'm going to fix the column values by putting a string value in front of them. Gives me the same value, but I'm going to copy it from here to here. 442. But this time I'm going to change the Y to a no, and it'll give me the average of those who aren't on the SEN register. The same deal here, I'm going to put in my AverageIF formula for the free school meal status. And I'm going to say the criteria is yes, and the range for copying and the range for calculating, as before, close my bracket. Average if free school meals is yes, is that. Reduce it, put it in the center. This value is going to get copied over to here. So I'm going to have to fix my strings, my columns. The same formulae, but I'm going to copy it over to there. And in this column, free school meals is no. So there we have a very quick and dirty way of very easily comparing a set of data for the total points score and breaking that into female and male, SEN and free school meal. So I guess the next question comes out would be, okay, there are differences here, but which is the most important difference? Now, interestingly, some of these differences are so big that actually maybe further processing isn't needed. But there is a test built into Excel for doing this, and that's called a t-test. And what a t-test does is it looks at two groups of data and it assesses, are they different, or are they different enough to be considered significant? If they're the same, if if the groups of data look like they actually could have been taken from the same group of data, the t-test will give you a value, a numerical value, that is quite a high number. If the two groups of data are sufficiently different, the t-test will produce a number that's quite low. And the value of 0.05 is the value below which we say things are significant, we need to take notice. And if it's above that, if it's bigger than 0.05, we start to question whether or not that difference is important enough to do anything about. Okay, so we need to find groups of data this time, again for t-test. I'm going to do it here. I'm going to do t-test. Okay, and it's looking for two arrays of numbers. So just as before, I need to sort things out according to how I want the t-test to go. So if I sort by sex, so I've now got all females at the top here, I can push a t-test of all of the data here, same as before. I've sorted them by males and females, so I'm just dragging out a column of females to there, comma. My next array is the array of male data. So I'm going to drag out my male data. Now it's asking for one or two-tailed distribution. Now, my distribution is about a mean value. Yeah, these scores can be any score, and the average of which, that can extend above an average or below an average. There isn't a cut-off value. So I'm going to say it's a two-tailed distribution. So in here I'm going to type a 2. Now it's asking for paired information about the variance, really. This is the most generic case of a t-test. So paired would imply that in some way there is some relationship between the two sets of data, if it was, say, before and after data. So we haven't got that. We've got two completely independent sets of data, boys and girls. And actually we're going to say that there's unequal variance, which is we're making no assumptions about the data. We're not saying that the data is in any way, boys could well be more spread out in their data than girls. We've got no reason to assume that the data is going to be equal. So I'm going to do 2, 3, close the bracket, and process the t-test. I scroll up, it's giving me a t-test value of 0.216, some other decimal places. Remember what I said? 0.05 was the value around which we start to sit up and take notice and think, gosh, that's something that we might need to do something about. So a t-test value of 0.2169 for sex is actually above that. And, if we were investing money, we would be at that point where we'd be thinking, no, this effect isn't big enough for us to do anything about. Or, this cure for a particular disease isn't good enough to consider the fact it works. So we might be considering that even though it looks like there's a difference between the boys and the girls' performance, actually it's not significant. It's not different enough to start to think to do something about. Okay, so this was the sex one, the t-test value for sex. Now I want to do the t-test value for SEM. And actually this is where Excel falls down, because if I now want to calculate the value for t-test for SEN, I have to sort the data by SEN. And when I sort the data by SEN, it's going to change the t-test value over here. Okay, now that t-test value is not going to do with sex anymore because we've resorted the data. So I guess I could have written it down like I did initially. I could write that down somewhere in a form, in a table, and redo everything, just like we did at the start with the sex, SEN, and free school meal. But actually, there must be a better way of doing this, just like we had with AverageIF. And there is, just slightly more complicated, as always. So we're going to start to compute the t-test, okay? And now it's asking for an array, and we're going to think about this in terms of, I want to put an if formula in here, because what I'm going to try and do is, if this is a female, chunk the data over here into the first array, and if the data is a male, chunk it into the array number 2. Let's just see by example and it'll make sense. So if, okay, my logical test is going to be if this column of data here, if that, a big column of data, B5 to B132, okay, if it equals a female, that's my logical test, right? If it is a female, I want to copy the corresponding value from over here into the first array. Yeah, so if B5 to B132 is female, I want to copy the corresponding value from BJ5 to BJ132. If it's false, I want it to do nothing, which is 2 inverted commas next to each other. Okay. So that if statement gives me array 1. If it's a female, chunk it over here. I now want to construct array 2, which is exactly the same as array 1 actually. It's the if statement, so I'm just going to copy the if statement next to it. But this time, I'm going to change it to male. So if B5 to B132 is female, copy the corresponding value over here into array 1. If B5 to B132 is male, copy the corresponding value over here into array 2. Okay, let's go with this and see what happens. As before, I'm going to say it's a two-tailed distribution, and as before, I'm going to say it's got unequal variance. Close the bracket, and I'm ready to process the formula. Now, at this point, you press return, don't you? So I press return, it's not going to work. It's going to chunk up a value. And it's a little nuance here in how Excel is working. But what we're trying to do in this formula is we've got a column of numbers, see highlighted here, B5 to B132. And we're saying if that equals a female, we then want to pull across the corresponding value from BJ5 to BJ132. And where Excel is getting confused is, it's getting confused between columns of numbers and single values. It's kind of getting a bit confused over if it's a single value or a row, a column of data. And there is a really simple solution in Excel, and that is to convert this into what's called an array formula. And the way you make it an array formula is you hold down Shift and Control before you press Enter. And if you hold down Shift and Control, Excel puts these curly brackets on either side of the formula. Now, it won't work if you type in these curly brackets. You've got to press Shift and Control and Enter. It's now turned that into an array formula, and it's calculated the value, which is the same value as we had previously. Okay. The beauty here is I can now copy that as a formula. So I can copy that formula down. It's going to go wrong a little bit, but if I copy it to here, the logic of that formula is still there. We just need to edit it to make it correspond to SEN. So in the SEN column, we're looking at column C, and the two levels are yes and no. So I'm going to go back into the formula here now, and I'm going to change that to C5. Everything's gone up a number, isn't it? Equals yes. I'm going to copy BJ5 to 132. If C5 to C132 equals no, I'm going to copy, whoops, that didn't work, yeah. I'm going to copy BJ5 to BJ132. If I press return, it'll say value. Remember, it's wrong. I need to process it by pressing Control, Shift, and Enter. Wow, look at that. 1.32 E06. That's Excel telling me that that's an incredibly tiny number. And look, if I try and make it smaller, it's not going to work. It's always going to display it in this what's called scientific formula. E minus 6 is telling me that there are 6 zeros in this number. If I try and display it here by clicking on number, and I expand the boxes, eventually I get to that value. Let's put 6 of these in before we get to the data. It's a very small number. Okay. I'm going to copy the formula down from here into here. Bear in mind we're doing free school meals, which is in D. So I'm going to edit the formula as well over here. If look, I'm wrong here, haven't we now? This is wrong. This one here should be if C5 to C132. There we go. C5 to C132, C5 to C132, B's, ordered the formula. Okay. So I'm going to drag the formula down into here, and in here we're referring to column D. So I need to edit the formula to say D5, D132 equals yes, BJ5, BJ132, D5, D132, BJ5, BJ132. This time I'm going to hold down Shift, Control, and Enter. And it's given me that number. I'm going to expand the number of decimal places. See how far we get before we get to a 0. There we go. So what we've calculated here are t-test values, or actually what in statistical terms gets called a p-value, but it doesn't matter. They're the t-test results for sex, SEN, and free school meals. Okay. So whilst all of these three have a difference between the mean values for sex, free school meal, and SEN, okay. In this case, sex going from 541 to 499. The t-test is telling me that that really isn't a big enough difference to actually worry about or to start thinking about. It's nowhere near this value of 0.05. But interestingly, SEN and free school meals are well below that value, so they're sit-upable and take noticeable values, so to speak. But what's interesting is just how much more important the free school meal values are. Yeah, a number of orders of magnitude, yeah, 100, 1,000 times more important free school meal is than sex. So if I was in this school and I was analysing this data, the single most important factor across the school is free school meals. So if I was putting in an initiative, I'd start with free school meals, and I'd give that time to run. I'd monitor my free school meal learners, impact of poverty on attainments and all that kind of stuff. And then I would think about the impact of sex, and only then would I start, and then I'd think about the impact of sex, and then I'd think about the impact of SEN, and then and only then would I think about the impact of sex. It's interesting that you can do exactly the same analysis for all of the data in the school, for all of the subjects. And I'm not going to go through that because it would take forever, but I have already created it here on this sheet. So what we have is exactly the same as before: free school meal, SEN, and sex. Okay, and I'm calculating the t-test values the same as before using that array formula, and I'm color coding it from green, as in not important, through to red, being most important. And you can go through each subject in turn. Now, in my case, I'm interested in science. So if I scroll all the way along the list here, I get to GCSE, here in this column here, GCSE core science. Okay. Now, for core science, the top two figures here aren't significant. And in fact, the bottom one, so none of these three, which are free school meal, SEN, and sex, okay? So those values there for science, in this column over here for science, none of those things are actually significant. You know, the most significant, still not significant, but the most significant, I guess, is sex. But the rest doesn't matter for core and additional science, that little block of data there. Now, that's quite a misleading figure, because if I scroll back over here and I find my values for applied science, yeah, diplomas in applied science, first certificate in applied science, okay, so the two GCSE BTEC course, what I find is that actually the values for free school meals and SEN give me a t-test value of 0, which is totally highly significant. For some reason, free school meal learners and SEN learners really are struggling on the first certificate applied science course, yeah, the two BTEC versions. Interesting, that's less on the 4, so there's something going on there, maybe. Now, we can kick this around and we can look at it and stuff, but we have a similar thing that we can consider now for, say, maths, English, and science. We scroll this along and we find maths is here. The bottom number here is gender, sex difference. And maths don't have a sex differential problem here, but they have a highly, highly significant free school meal and SEN issue. We find English in the list here. English have a slightly more significant sex differential, but still not below my critical value. But again, they have a highly significant free school meal and SEN issue. So we can go through all of these values looking at the importance of free school meal, sex, and SEN by calculating these t-tests. We do a similar thing, I guess, by calculating them overall. Okay. But by using the formulas AverageIF to get these average values linked to a criteria, and by taking our t-test and wrapping it round in an array formula, we can very rapidly take a data sheet and we can find the most important factors for each subject. Or actually we could do the similar thing overall, the most important factors overall. So that's using Excel to calculate significance and averages to help us analyze data in school. Thank you.